Alright, time for the solutions for more solutions on the real world situations with systems of equations. So I'll read through this one, make sure you're familiar with all the different things and figure out what variables you're going to use. So for this one I chose little b to be the number of small boxes and big B to be the number of large boxes. I'm going to use these two variables. And I do have a, let's see, a couple of totals here. Total of 203 and a total of 220. And so really I can make two different equations just from those totals. I got one total of 203 and another total of 220. And this first total comes from 3 small boxes and 14 large boxes, and that just comes out to be, well, just 3 small boxes and 14 large boxes. And so now I got my first total there. So looking at that, I had to make a quick change to what my b and my small b and large b represent. The small b would be the cost of the small boxes, and then the large b would be the cost of the large ones. And if you do 3 times the cost of the small, that gives you the cost of 3 boxes. Anyway, so that gives my first equation. My second one is going to come from 11 small boxes and 11 large boxes. So 11 small b plus 11 large b. And that'll be actually my system. I got 2 equations with 2 unknowns, and I can solve them both. Alright, so here I have my system, and I think as of right now, it'd probably be easiest just to take my second one and solve for the little b, because I notice everything here is divisible by 11, and so I can just solve that fairly easily by subtracting 11 large b from both sides. That should be a b, not some weird squiggle. And we'll get 11b, 11 small b equals 220 minus 11 large b. And you just divide everything by 11. We'll get b equals 20 minus large b. And so what this tells us is that the number of small boxes is equal to 20 minus the number of large boxes. So there's 20 boxes. There's the cost. So the small ones are equal to $20 minus the cost of the large boxes. So their total cost comes out to be $20. Anyway, I can take that small b and put it into my first equation, and that'll help me solve for my large b. So I'll put 3, and then what small b is equal to, which is 20 minus large b. And then add 14b equals my total up there of 203. So now I have this, again, work towards getting my large b by itself, so I need to distribute. And now I need to subtract the 60 from both sides, and I'll combine my like terms while I'm at it to give me 11 large b equals, oh shoot, what's 203 minus 60? That'd be 143. And you just need to divide both sides by 11, and you'll get large b equals 13. And I can take that 13 and plug it into my equation right there where I solve for little b. That's going to make little b equal to 20 minus 13. So little b is, little b is equal to 7. So the cost of the big boxes is $13, and the cost of the small boxes is $7. So moving on to 9, read through that and trying to figure out what your variables should be. So here I've chosen lowercase n to be just one number and capital N to be the other number. And you can actually just kind of read through this and get your 2 statements. The 2 numbers and their sum is 12. That just means that lowercase n and uppercase n add up to be 12. And their difference is 4, so n minus n is going to equal 4. And now we have our 2 equations. It's actually very quick. We can actually put this just on the same screen here. I'm going to solve the second one for little n. I'm going to add capital N to both sides. We get n equals 4 plus large n. And that plus is hideous. And now I could take this and plug it into my other equation, which is right there, for that n, and that'll give me 4 plus capital N plus capital N equals 12. Well, I can get rid of those parentheses. I really don't need them. They don't do anything because there's no number in front. So I can subtract 4 on both sides, and I'll combine like terms to get 2n equals 8. Divide both sides by 2. You get capital N equals 4. And I can take that number and plug it into my other equation to get lowercase n equals 4 plus 4. So lowercase n is 8. So our two numbers are going to be 8 and 4. Their sum is 12 and their difference is 4. And there we go. Let's move on to 10. Read through that one and figure out what variables you're going to use. Alright, so I'm just going to use the same variables as last time. Lowercase n is just going to be one of the numbers, and uppercase n will be the other one. And my first statement actually gives me an equation like read out. Their difference, meaning subtraction. So one number minus the other is going to give me 3. And the next statement, their sum is 13, gives me my other statement. So lowercase n plus capital N is going to equal 13. So there we go. I'm going to solve this I'm going to just do this the same strategy as last time. I'm going to solve my first equation for little n. So I get 3 plus capital N. And I can take that and substitute into my other equation to get 3 plus capital N plus n equals 13, and that should be in parentheses, but the parentheses don't do anything in this case, so let's just solve for n by subtracting 3 on both sides, combining like terms. You'll get capital 2n, and on the right side you just get 10. Divide both sides by 2. Capital N is going to be 5. And you can take that and plug into the equation that solve for little n. So you'll get little n equals 3 plus 5. So little n is 8. So their difference is 3, their sum is 13, and those are our two numbers. Actually, really similar to the last problem. And let's do 11 here. Read through this, figure out what variables you're going to use. Alright, so these are two variables I'm going to use. I'm going to use this P to represent the number of pigs, and C to represent the number of chickens. And look for the statements that give you some sort of totals, and that's these two. First one saying that there are 13 animals in the barn, so the number of pigs plus the number of chickens is going to equal 13. Just P plus C equals 13. And it says there's 40 legs in all. Well, that'll give you a total of 40. Well, how many legs does a chicken have? That's just 2. So you should do 2C, 2 times the number of chickens, to get that many legs from the chickens. And there's 4 legs on a pig, so you're going to do 4P. And that's going to be my second equation. 2 equations, 2 unknowns. I can now solve it. I'm going to take this first one and just solve for C. So I'll subtract P on both sides. So C is equal to 13 minus the number of pigs. And I can take that and substitute in for C in my other equation. So I got 4P plus 2 times 13 minus P. That's going to equal 40. And now I can distribute the 2 to get 4P plus 26 minus 2P. And that'll equal 40. I'm going to subtract the 26 from both sides. 26. And I'll simplify my P's, combine like terms there, to get 2P equals 14. And divide both sides by 2 to get P equals 7. So there's 7 pigs. Take that 7, plug it into my other equation. C equals 13 minus 7. So the number of chickens is going to be 6. So 7 pigs, 6 chickens, and we're good to go. That'll be this video.